Hello, everybody. Thank you for hosting us from Turkey. On behalf of Turkish Chamber of Civil Engineers, my name is Kahramanmaraş. I'll be explaining the 6th of February 2023 Kahramanmaraş earthquakes. And let me start sharing my screen first. I think you all see what I'm showing right now. On 6th of February 2023, Turkey, the part Kahramanmaraş, actually suffered a very high magnitude earthquake, and we've been there for the site investigations. And I'm from Ankara Atılım University Civil Engineering Department. My name is Halit Cenan Merto, and not only me, we had a team of professors that were with us, and we went to the sites that were affected due to the earthquake, and then that's what we found out at the end of our observations. By the way, thank you for hosting us on the 8th International Conference of Construction Safety and Health. And first of all, I'll talk about the earthquake activity in Turkey, earthquake activity in the region. Then we're going to talk about site investigation, what we have done or what we have seen, and issues related to reinforced concrete. Then earthquake specifications in Turkey. I'm going to explain some information about earthquake specifications in Turkey. Issues related to reinforced concrete buildings will be explained later. And at the end, we're going to talk about the conclusions. And first, earthquake activity in Turkey. Turkey, why this all happens is that since we are sitting on the plates, we have the Arabian plate that is pushing Turkey towards north, and the African plate actually pushing Turkey and Cyprus towards north also. At that time, Anatolian plate wants to go to the west towards Greece. At that time, there's a motion in here on the south-west direction, so that everything is actually moving. Therefore, at the fault lines where we have the cracks of the crust, we have these fault lines at the end. This is called the Eastern Anatolian fault line, and this is the North Anatolian fault line, and we have the small fault lines here, but the main fault lines are located in here. And if I want to show the detailed fault lines in Turkey are North Anatolian fault line, East Anatolian fault line, and West Anatolian fault line. By the way, we had an earthquake in Izmir in 2020 where it was due to the West Anatolian fault line. Right now, this earthquake actually happened at the East Anatolian fault line, and these are the locations of the earthquake. And due to those fault lines, we have an earthquake risk map in Turkey, and the darker colored locations are the locations where we have more earthquake affected regions, and the lighter color, the yellow colored locations are less affected regions. Actually, 92% of Turkey, 95% of our population, and 95% of our main industrial regions are in the earthquake affected zone. And at every 1.5 years, we have a medium earthquake, and at every 3 years, we have a high earthquake, and at every 35 to 40 years, we have devastating earthquakes. And this was a really devastating earthquake, by the way. And let's talk about the earthquake activity in the region. Actually, this region is very active, and we know the fault lines in the region, so that these are the fault lines in the region. And actually, in that region, we had some historical earthquakes also, starting from the born of the mankind, let me call, like 500, 600, 1343, 1114, 1544. we have many earthquakes, so that this zone is really active in terms of earthquakes. And our earthquake, the last one, which happened on 6th of February, there were two earthquakes actually back to back. The first one happened in here, we call it Pazarcık earthquake, and then the other one happened in here, we call it Elbistan earthquake. The first one's moment magnitude was 7.7, and the second one's moment magnitude was 7.6. And actually, these cities are the cities affected, uh, adversely affected due to the earthquake. And this is the location where earthquake happened. And as I told you, we had two earthquakes back to back. How back to back? Like the first one is actually these are the measurements, the readings of the different locations in the world. And in Turkey, you had two locations which calculates the magnitude of the earthquakes. And it happened at 4:17. The first one in the morning, not in the morning, just before the morning, 4:17 a.m. And the magnitude was close to 7.7. For other locations, they measured a little more, but 7.7, we can call it 7.7, and it happened in Pazarcık region in Kahramanmaraş. And the second earthquake actually happened 13:24 in the afternoon, okay, the same day. And its magnitude was 7.6, 7.6, 7. We talk about it as we name it as 7.6 Elbistan earthquake. And we had different focal depths measured by different locations. But the first magnitude was, the first earthquake magnitude was 7.7, and the second earthquake's magnitude was 7.6, happened at the same day, which are very close to each other. And I will show you a video of the earthquake, what happened in the earthquake.
Koş. No, no, no. Umut! Hayır! Hayır! Bakma sen.
It was really very devastating for Turkey. And in that region, we knew that we had some fault lines here. There were many strong ground motion monitoring stations right here, and they gathered some good information. What they found was that in the first earthquake, the morning earthquake, 4:17 earthquake, actually the earthquake happened somewhere in here, and it's mostly affected the southern part of Turkey. These parts are more affected. The upside is not affected that much. The next earthquake, where it happened in here, it actually affected highly the northern part, the Malatya part, I can call. The southern part was not affected that much for that earthquake. And after the earthquake, we had many aftershocks. You can see the locations of the aftershocks and their magnitudes. What are the magnitudes of them? And as I told you, the earthquake happened 4:17 and 13:24 in the afternoon, the same day, 10.7 and 7.6 earthquakes, and it affected these 11 cities: Adana, Osmaniye, Hatay, Kilis, Gaziantep, Şanlıurfa, Kahramanmaraş, Adıyaman, Diyarbakır, Elazığ, and Malatya. We had collapses in these cities. And to sum up how much collapse we had like in Hatay, 65,000 buildings severely damaged or collapsed. So that Hatay actually has seen the highest devastation. Then we had Kahramanmaraş, 40, close to 49,000 buildings damaged. And Malatya and Adıyaman were the other cities that were affected a lot. 31,000 buildings in Malatya and 28,000 buildings in Adıyaman. But the Malatya region, we didn't have a lot of life loss because Malatya region was affected more in the second earthquake, where the buildings were deserted at that stage. And I'm going to talk about our site investigation. After the first earthquake, which happened in the morning, 4:17, actually, I'm living in Ankara, and we arrange a vehicle. And with that vehicle, we directly start going to the earthquake affected regions. First, we went to Adana, and in Adana, we actually been in the earthquake region 18 hours after the first earthquake. Then we stayed in this region for 5 days. And after 5 days, what we've seen, we've been first to Adana, İskenderun, Antakya, then Kahramanmaraş, Pazarcık, where the first earthquake's location, epicenter is located, and then Adıyaman, Besni, Gaziantep, Nurda, Osmaniye, so that we have seen all of these locations, many buildings in these locations. And 18 hours, we went there 18 hours after the earthquake, and then we stayed there for 5 days. And what we have seen, I'm going to show you the previous photos and after the earthquake photos. This is in Adana. There are many buildings actually collapsed. I'm going to show one or two pictures from each location. In Adana, this was the before the earthquake photo, after the earthquake photo. And in Adana, another one. This is another apartment, Sinem apartment, before the earthquake, after the earthquake. And in İskenderun, there was a really big fire in the İskenderun port, naval port. And let's see.
İskenderun limanındayız. Konteynerlerin yanışı. Depremin ikinci günündeyiz.
This is the second day of the earthquake. And then we've been to İskenderun after Adana. And in İskenderun, the city center was actually in a very bad condition. Let me show that to you. After İskenderun, yes, I can show some photos from İskenderun before the earthquake, after the earthquake photos. Sarıkonak apartmanı, another apartment before the earthquake, after the earthquake. And then we've been to Antakya. Antakya and İskenderun are in Hatay city. And Hatay had the highest level of damage throughout all of these cities. It was really, really bad. And I can show you some before and after the earthquake photos. Before the after the earthquake. And there was a very important structure, I can call it the Renaissance residence. And in this Renaissance residence, and we had a 3-block constructed side by side, as you can see here. And there was another block B, actually constructed right a little far away, that the first A1, A2, A3 blocks. And what happens is that this is the before the earthquake pictures, and this is after the earthquake. Actually, it actually turned over towards the front side, towards block B. And we've been here in the second day. There was a fire in the building, And you can see some pictures of these buildings. Renaissance residence. And then after Hatay, Antakya and Iskenderun, we went to Kahramanmaraş. On our way to Kahramanmaraş, actually, we have seen a fault line which passed the railroad and actually damaged the railroad like this. Then we've been to Kahramanmaraş. Kahramanmaraş, it was also very bad after Hatay, as you can see. Before and after, this was before after Serap Apartments. Before after Kahramanmaraş. And then we've been to Adıyaman. This is the Turkish Telecommunications Center in Adıyaman. This is after the earthquake. And in Adıyaman, another picture. And then we've been to Gaziantep. In Gaziantep, there wasn't a lot of damage, and this building complex had 3 or 4 buildings collapse. And then we've been to Osmaniye. This was the last location that we've been to. It was before and after the earthquake. That's what we see. Okay, right now you have seen, you have right now some general view of the sites. And then what I will explain is I'll explain why these all happened, why they had that much of damages. And I'm going to explain this in light of Turkish earthquake specifications, okay? And actually, the first earthquake specification in Turkey was published in 1940, and then we had many updates for that. But it's important to underline the last 4 of them: 1975 specification, 1998, 2007, and 2018 specification. Why I'm emphasizing 1975 specification? Because like more than 90% of the buildings that were collapsed in this earthquake was constructed after 1975. Okay, then you need to know 1975 because they should have been constructed based on this 1975 specification. And our last Turkish earthquake, the 2018 Turkish building earthquake specification, tries to do this in a low intensity earthquake. We expect no damage if you design based on our specifications. In a medium intensity earthquake, there should be some damage, but it should be repairable. And in a high intensity earthquake, we need to prevent collapse. This is what we aim in our specifications. And what we have seen in reinforced concrete building problems. So first of all, I'm going to explain the insufficient development length. What do I mean? Actually, this is the column and this is the beam, and these vertical reinforcements are the long-term reinforcements in the column, and these horizontal reinforcements are the long-term reinforcements in a beam. And this is with the stirrups, without the stirrups. If I take the stirrup, the view of the stirrups out, I see this. Normally, the beams and columns reinforcement, actually beam long-term reinforcement, top and bottom reinforcement, shall be placed into the column and bent in the column so that it will not pull out from the column. Okay, this is what we have in our specification. And if we satisfy this criteria, when the earthquake comes to the building and the building moves, there will be no separation between the columns and beams, okay, because those joints will actually move together. But there's a wrong application of this, where the top and bottom reinforcement of the beams actually are not bent in the column. They just move, actually, they extend in the column a little and then stop. This is the wrong application. And if we have this wrong application, what happens is that when the earthquake comes to your building, when the earthquake load comes to your building, the beams and columns will get separated like this, okay? When it comes from here, the bottom side will get separated. When it comes from the right-hand side, the top side will get separated, and the integrity will be lost. And actually, we knew this in 1975. Our 1975 earthquake actually shows that the beam reinforcement at the top and the bottom shall be bent in the column. And 2018 earthquake specification has better drawings, but it's doing the same stuff. And we have some calculations for those bent legs. And what we have seen, this is from Antakya. This is the bottom reinforcement of the beam, actually long-term reinforcement of the beam. It actually is extended in the another beam, but we didn't see any bent parts. Also, another one. This is the same apartment. Also, the bottom reinforcement actually it ends. There is no bending of longitudinal bars at the joints. This is a very big problem because when the earthquake comes, the integrity will be lost. You may not be able to talk about any other stuff, not about concrete quality, not about steel strength, not about any other stuff. So that when the earthquake comes, it will fail immediately. And another pictures from Kahramanmaraş. Look, you can see that they're not bent and they're a little extended and then stop. Also in here is the same, so that they get separated. We lose the integrity of the structural element. Then ends of the stirrups shall be bent 135 degrees. What does this mean? To prepare a stirrup, actually you get a long, this for the rectangular stirrup, you get a longitudinal reinforcement, a long reinforcement, and then bend first the top part 135 degrees towards inside, and then bend the rest of them. At the end, when you bend it like this, we had two legs like this. This is bending the stirrup ends at 135 degrees. And when you prepare the reinforcement page of the column, you will prepare it like this. And when you test concrete, it will look like this, up to half of it. And then what happens is that when you bend them 135 degrees, it means you are actually anchoring the ends of the transverse reinforcement, the stirrups, in the core concrete, not in the cover concrete. And when what happens is that when the loads are applied in this column, the cover concrete, actually which surrounds the transverse reinforcement, the stirrups, will be lost. It will be gone when they're under load. However, the concrete inside also wants to get big. At that time, transverse reinforcements keep it in place since the ends are anchored to the core concrete. And then it will be actually what happens that you lose the cover concrete, and then, however, when you bend the ends of the transverse reinforcement towards the core concrete, you will not lose the core concrete, the concrete in the core area. And there's a wrong application of this transverse reinforcement stuff. And what you do is, instead of bending this end to the core concrete, you bend it 90 degrees. We call it at 90 degrees bend. And when you bend 90 degrees, at the end, you will have the ends of the transverse reinforcement bent like this. And when you prepare the reinforcement cage, the ends are 90 degrees bent. However, when the load is applied on this column, it can be also beam, it doesn't matter. The cover concrete is lost because there is nothing holding the cover concrete. But the core concrete is actually held by the transverse reinforcement. But the ends of the transverse reinforcement, when the concrete wants to get big, opens up like this. And they are useless. Okay? If you are using this type of transverse reinforcement, it's better not to use them. It's not better. They have the same effectiveness of having 90 degrees bent transverse reinforcement that no transverse reinforcement. And this is what happens in the earthquake. Initially, you have the 90 degrees bent bars, transverse reinforcement, the stirrups, and then the stirrups are lost because they open up. You will have only the long-term reinforcement and core concrete. And then, since nothing is holding it, you will also lose the core concrete and then everything. You will lose everything. And actually, the transverse reinforcement acts as a second duty, let me call it. Aim is to resist the shear forces. And we also call it the shear reinforcement, transverse reinforcement. And when the earthquake load comes, each column resists shear forces by themselves. And then if you have 90 degrees transverse reinforcement, when the earthquake load comes like this, there will be a crack like this. And from the other side, there will be another crack like this. However, since the transverse reinforcement opens up, it means you're not using any reinforcement, any steel reinforcement to resist these forces, then your column will also fail due to 90 degrees bent stirrups. And it was known in 1975, by the way, in our Turkish standard 1975. You can see, we don't have a very good drawing, but you can see the ends shall be bent like this. In 2018, we have better drawings. It explains 135 degrees, and then for the beams, for the columns, you can see how you need to do them. And actually, we've been to many cities. We have seen many buildings that collapse, and in none of them, we have seen both ends of the stairs bent 135 degrees. In all of them, we have seen both legs were 90 degrees. You can see there's 90 degrees from Adana, 90 degrees, 90 degrees. Another one, Istanbul, 90 degrees, 90 degrees, 90 degrees. This is from Renaissance residence, and 90 degrees, 90 degrees, 90 degrees. Another one in Kahramanmaraş, 90 degrees, as you can see, 90 degrees. In Adıyaman, 90 degrees, 90 degrees, 90 degrees. The transverse reinforcements were all 90. This is basically in Adıyaman. 90 degrees, 90 degrees, 90 degrees, 90 degrees. All of them were 90 degrees. This is from Gaziantep, 90 degrees, 90 degrees, as you can see. None of them were, both ends were 135 degrees, but in Nurda, in only one location, in one collapsed building, we have seen that one end was bent 135 degrees, but the other end still is 90 degrees. Actually, bending one end is not important. The other end will open up, and it will open up all the way. Okay, and then this is from Osmaniye, 90 degrees and 90 degrees, how it opened up. Okay, and we have seen some constructions that are in progress in the earthquake regions, but it is in Kahramanmaraş. In this region, many of the buildings were collapsed in that street, and we have seen there was a new building that was constructed, and in here, one end was 135 degrees of the stirrup, and the other end was 90 degrees. It was a little bit longer, but it was 90 degrees. I think it's not, still, they're not constructing the way it should be. However, it's not the same in all the construction locations. This is from Osmaniye. In Osmaniye, you can see there were bent 135 degrees. And in Adıyaman, you can see that the transverse reinforcement also bent. This is this part of this construction. You can see there are 135 degrees bent. In some of them, they are still not doing it. And let's talk about some concrete and steel problems. The concrete was not high quality in the collapsed buildings. They have rounded aggregates, and in some of them we don't see coarse aggregates. The color of the concrete was really weird, and they used some large aggregates. I cannot call aggregates, like I can show some of the pictures, like these are very big, like 10 to 15 centimeters aggregates, and not only the size of the aggregates affects the concrete quality, also some materials that shouldn't be used, like wooden pieces or some garbage stuff, also were in concrete. And steel, yes, we had also problems with steel, and corrosion problem. You can see the effective area was reduced to half of the original area in here. The corrosion, you can see the corrosion. Also, the placement of the reinforcement was not correct in some of the buildings, like concrete cannot pass through here, and enough bonding cannot be provided in these mislocated reinforcement. And confinement regions, another problem. Actually, in 1975 specification, we had this ends shall be confined with stirrups, with more closed space stirrups. Not only ends of the beams, also the column ends shall be confined with stirrups. This is from 1975 specification. And our latest specification, 2018, has better drawings, as you can imagine. Like we have, but in this ends of the beams and ends of the columns shall have more closed space stirrups, which will create confinement regions at the ends of the beams and at the ends of the columns. Why? Because we know that those locations will be affected more. The more load effects will happen at the ends of the columns and beams. This was known, but in none of the, not none of the, in most of the collapsed buildings, we have seen that there are no confinement regions on the columns and at the ends of the columns and at the end of the beam. Not all. We have seen in some of them we have. And from Antakya, Kahramanmaraş, other examples of these buildings. And the strong beam, stronger column condition. Actually, this is the philosophy under our earthquake code. What happens is that we know that the plastic, actually, we know that this way, we know that high energy dissipation is the aim in our specification. How do we do that? We do this by locating the damages in the structural system. How? What we do is we construct the beams strong, but the columns stronger. Therefore, when there's a connection joint, what will happen is at a joint, the beams will fail since they are weaker than the columns, but the columns will not fail. And when you satisfy this criteria, the plastic hinges will happen at the end of the beams, not at the end of the columns. And then for this beam to fail, all the ends of the beams shall have damage, and then this building will fail, but it will absorb a lot of energy. However, if you do the opposite, if you make the beams stronger than the columns, what happens is that the beams will not get any damage, the columns will get damage. And after getting the damage or the plastic hinging in the first story columns, where this is a critical location, the building will fail. And it will fail without any dissipation, not a little dissipation of energy, it will fail. Actually, to satisfy this criteria, our earthquake code tells you this: the resisting moment capacities of the beams, actually, resisting moment capacity of the columns shall be 20% greater than the resisting moment capacity of the beams. This is how we satisfy this criteria. Therefore, the locations of the damages and which will convert to plastic hinges will happen at the end of the beams, not at the column. And so that what we have seen is this is a picture of what we don't like. There will be some damage at the bottom of the column, but we don't want the next damage happen at the top of the column, first story column. And what we want the columns not to fail like this, and the beams to fail. Look, this column, by the way, the plastic hinging at the bottom of the column are unavoidable, so that there will be some plastics at the bottom of the column. But after that, we don't want any damage to happen on the column. And if this happens, the buildings, even though how much they will get damaged, the building will not collapse. And if you do opposite, the columns are weaker than the beams, columns will fail, and your first story columns will fail, and then your building will actually sit on the ground with the second story right here. Another example of that. And another problem, actually, these are the basic problems. There are many problems in the collapsed buildings. These are some basic problems, and this is actually a more advanced problem, I can call hammering effect. What happens is that when you construct two buildings side to side, they will move in a different way in the earthquake. And let me show a picture of a model or a video of a model. Your building will move like this. And if you are constructing two buildings side by side, you need to give some space in between. And in our earthquake specimen, we knew it in 1975. These are in Turkish, but I'm going to translate it to you. Up to 6 meters, you need to leave 3 centimeters in between two adjacent buildings. And at each 3 minutes after 6 meters, you need to place 1 centimeters joint. We call it joint. You can call it joint. Space in between two. And then it was in 1975. We knew this in 1975. In our 2018 specification, we have the same criteria. And if you don't satisfy this criteria, what happens is that the buildings will actually hit to each other. Let me show a video of that. This is also a very bad thing to happen because we don't calculate these forces. We calculate the other forces, but not a building hitting to your building. Therefore, there should always be placed some space, which is a joint, because expansion joint, and we had some damages due to this hammering effect. And at the end, we have some space in between, naturally located space. Okay, another issue is an inspection issue. And actually, the inspection of the construction works were not mandatory up to 2001. Then in 2001, after our Izmit earthquake, 1999, and it became mandatory. First in some cities, and then all throughout Turkey. The first 3 cities, Adana, Gaziantep, Hatay, the inspection of the construction works were mandatory after 2001. And the other cities that were affected in this earthquake, Adıyaman, Diyarbakır, Elazığ, Maraş, Kahramanmaraş, Kilis, Malatya, Osmaniye, and Şanlıurfa, the mandatory inspection was effective after 2011. However, there was still problems with that, and in 2019, actually, they tried to fix this problem by introducing a new law. And after that new law, the ministry will determine randomly which inspection company will be assigned to construction, because you had the chance to select the company and pay to that company. And if that company does not, okay, whatever it does, if you don't like it, you can change it to another company and then pay to the other company. But there were some inconsistencies, and they actually fixed it in 2019, after 2019. And actually, in the earthquake affected regions, there were some buildings that had only hairline cracks. You would never realize, maybe, if you don't look very closely. And these are buildings, newly constructed buildings, so that, and it was a weird building, but still it didn't have little hairline cracks, maybe at most. So that another building in Kahramanmaraş, also, it didn't have, it had hairline cracks, that we call hairline cracks. It didn't have moderate or heavy damage. So that if you construct based on the specifications, actually they are standing still without having any important damages. Okay. And as a result, we come to the end. As a result, the problems are many, and as a conclusion, existing buildings do not comply with the specifications valid in that construction period, even 1975. They're not obeying the rules in 1975. And maybe mistakes were made during construction. And however, this is important stuff like you need to at least specify, at least follow the specifications. And problems related to building inspection, it was, as you can see, nobody obeyed the specifications for the collapsed building. And deficient buildings, the more important thing is this earthquake happened in that region with 11 cities. But if this happened in another location in Turkey, we will see the same consequence, same reason, same conclusions, meaning there will be many losses. And therefore, throughout Turkey, we need to either strengthen the deficient buildings that are not complying with the standards or demolish them based on economic considerations. And thank you for listening me. And this is the team that we've been to the site of the earthquake. And if you have any questions, you can always ask to using my email address, cenan.merkel@atilim.edu.tr. Thanks a lot for listening. See you in another conference. Thanks. Bye-bye.